Hello, my friends. Welcome back. We are looking at enhancing the card game war project from the WiByte Python curriculum available at www.wibyte.in. Previously, in the class game, we demonstrated a straightforward way to deal the cards to two players, which was basically 6 cards go to player 1 and then the next 26 go to the player 2. In fact, this can be extended. So, for say, in case of 54 cards, we can say, well, look, first 27 go to the first player and next 27 go to the next player. But as I think about it, there are in fact pretty interesting ways to deal cards, and I thought this could be a nice way to enhance the project because it also shows connections to certain other fields and a pretty interesting way of thinking. So let's think through this a little bit. Clearly, what we are doing is just one of the many ways to deal cards because if I look at the factors of this number, that tells me a pretty interesting story. For example, let's say I have 52 cards. Now, of course, the first method, which is a class game, is that, well, give 26 cards to each player and you're done. But we can do it differently. We can say, okay, I'll give first 13 cards to one player, next 13 cards to the other player, and so on. That's because 15 is 3 times 4. So I have four such, let's say deals. So first 13, next 13, first 13, next 13, and I'm done. In fact, I can give first two to one player, next two cards to the other player, and so on and so forth. Because again, 52 is 2 times 26. So I'm giving two cards at one time, and totally I'm making, let's say, 26 deals. I can give one card alternately, which is 52 as 1 times 52. Now notice in all of this, I want the second number here to be an even number because there are two players. Clearly, all of this can be done with slicing, but as we'll see, for some of these, we need to write a loop, and that is actually quite interesting. Thinking similarly for, let's say, 54 cards, well, we can give 27 cards to each player like we saw in the class game. We can give alternately, say, first 3 cards to player number 1, next 3 cards to player number 2, and so on and so forth. So that's because, well, 54 is 3 times 18. I could give first 9 cards to player 1, next 9 cards to other player, and so on, because again 9 times 6 is 54. And of course I can give cards alternately because 54 is obviously 1 times 54. So once again, there are ways of doing this. There are multiple ways of doing this. Some can be done with just slicing. For some of these, we need to write a loop. So basically, it's going to be loop plus slicing. And that's probably where it's more interesting. Now, how do I implement this in code? Like I said, well, the first two methods are kind of simple. I can just do a plain slicing here. For example, here for 52 cards, I say, well, give first 26 cards to, let's say, player 1. Next 26 cards to player 2. I could do 26 to 27. Here, on the other hand, I'm saying give cards alternately. Again, I could just do it with a single slicing statement. I say, look, give cards start, stop, steps. So I'm going all the way to the end in, let's say, steps of 2. So basically, all even number cards go to the player. All odd number cards go to the computer. Now, in fact, very interesting. See how similar this is to even or swap, what we did in the secret messages, except that there we are working with strings. Now we are working with lists. But remember, slicing works with both of them exactly identically. However, in a more general case, which is, let's say an example I'll give you. For example, let's say I'm giving 2 cards to both players alternately and totally 52 cards. For this kind of a scenario, we will have to write a loop and write it quite carefully because this is not just pure slicing. There's some kind of logic going on here. So notice here, for example, 0, 1, 4, 5, and so on will go to the player. 2, 3, 6, 7, etc. will go to the computer. So here, a simple slicing won't do because the gap is actually not constant. Now, this is actually interesting. We have done things like this when we enhanced, for instance, the secret messages project. But again, we'll see this in, let's say, in this game here. One more example. Let's say I want to give 9 cards to both players alternately. So I give the first 9 cards to the player, next 9 cards to the computer, and so on. And this will obviously hold in, let's say, 54 cards. Again, we will have to write a loop. So my point is, in general, to sort of handle all these situations, we will have to write a loop, and that becomes quite interesting, quite powerful. Let's look at that. So what I'm going to do, and this will require a little bit of thinking, I'm just going to say, look, let me define a variable here called, say, NCD, which is, what I mean by this is like the number of cards given to every player per deal. So for example, let's say it's 2. So whenever I deal these cards, I know I give 2 cards at once to player number 1, 2 cards to player number 2. Now, given this, clearly the number of deals I'm going to make is length of deck of cards divided by 2 times NCD. Why 2? Because remember, there are 2 players, both are getting 2 cards each. For example, let's say my NCD is 2 and my length of cards is, say, 54. I'm going to be making 13 deals because 13 times 4 is actually 52. So each time 4 cards are distributed out, totally 52 cards, and hence I'll be making, that many deals. Now, what do I do within a deal? Now, this is quite interesting. Let's understand this from an example. Let's say my, let's say, like I said, NCD is 2. So I want to give the first 2 cards to my player, next 2 cards to my computer. Again, 2 cards to player, 2 cards to computer. Now I'm keeping a variable here called KK. KK is a counter variable that's counting from 0 all the way to end deals. In this case, say 0 to 13. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Now what I'm doing is that I'm saying, okay, look, go from 0. So I'm saying, well, go in multiples of 2 times of NCD. That's because, essentially we are giving 4 cards out each time. So I'm going, well, go in multiples of 0, 4, 8, and so on and so forth. So each time K increments, move to one of these ends. That's why 2 here. And pick up NCD cards. So I'm picking, for example, 2 cards. So I pick up these 2 cards. For the computer, again, I pick up NCD cards, but basically I'm a little bit offset. So I'm kind of offset by NCD here. That's the plus NCD. And I go all the way to the end of this branch. Now, this will take a little while to sort of understand. But do put some thought, and I'll be happy to discuss this with you. One important point to understand here is that each of these slicings is going to give you a list, and that's why I'm using the extend method, because I want this to be added, to the player cards. Sort of every item should be added as an individual member. Let's see this working, and then it will become a bit more clear. Basically, here I come to my code. Now I will, for the moment, let's say I will just, remove these 2 jokers. Not a big problem, but I just remove this because I want to build that piece of code where we deal these cards in a innovative manner. So here, of course, I'm dealing, let's say first 26 cards go to, in this case, first 27 cards go to, let's say, one player, next 27 cards go to another player. For now, I'm going to just say comment this out because what I'm interested in is more the loops that we are looking at. So I'm just going to say, well, player cards is, let's say, an empty string, empty list, and let's say computer card is also an empty list. Now, let's define NCD is equal to 2. So that's the number of cards given to each player per deal. Cards to each player per deal, and clearly n deals will be, well, length of, say, deck of cards, length, say, deck of cards divided by 2 times NCD. Now I must make sure that this is an integer, because only then this whole thing makes sense. So that's why I wouldn't want to do this with 54, because if I were to do 54 by 4, I'm ending up with 13.5, which doesn't make sense here, right? So I just want to make sure this is an integer. If I'll put a comment here, must be an integer, or let's say actually a whole number, because division will in fact make it a whole number, but never mind. So this should work. I'm going to say, look, for KK in range, say for KK in, say, range, let's say int, say n deals. So convert that to integer, because it's a whole number, so it can be converted to integer. I say, well, I have to do this a little bit carefully. I'm going to say, well, player cards dot, say, extend. Now this is where the slicing will happen. So I'm going to say, look, deck of cards, little bit carefully. So I'm going to start at KK times NCD times 2, going all the way to KK. Remember, start stop step. So KK times NCD times 2 plus NCD, and in steps of, say, 1. And likewise, computer cards will be, so if I were to look at compute cards, we will fix the indexing later. So I say, well, compute cards will be, well, deck of cards NCD plus times 2 plus NCD here, because there's an offset for the computer cards, remember. So I say, okay, let me just offset that a little bit. And it turns out that there has to be one more NCD over here. So that becomes essentially KK plus 1 times NCD times 2. And this is what I would like to do. Now, obviously, this requires a bit of thinking, but I'm happy to discuss with you. In case you have any questions, please leave a comment. I will gladly be, I'll be very happy to sort of explain to you how this is working. work out some examples like we've done for the two card case over there, and that will become very clear. But having done this, in fact, I expect this to run now just to test my code right now, because it's very hard to figure out what exactly has happened here. But just to test my code, just for now, what I will do is that I'll put and so first of all, I'm going to hold my game over here. So input, let's just say I will say, well, let me uh, for now, okay, just for now, I'll say, well, deck of cards, let's say, is a list going from 0 to 51. So I say, well, is, let's say, n say for n in range say 52. Now what this will do is that it will give me a deck of cards which is going from 0 until 51. And also, just for now, I will not shuffle it, because then I can figure out if my code is working correctly. So at this point, I can go and sort of print, let's say, print, let's say, player cards, and I can also print, say, computer cards. Let's see this working. So when I do, say, notice so I can ignore everything else here. The toss happened, the toss was won by the player. In this case, doesn't really matter. But see what has happened here, right? Basically my player cards are being printed first. My player card is 0 1 4 5 8 9 and so on and so forth, whereas my computer cards are 2 3 6 7 10 11 and so on. Now clearly this is because I've made my deck of cards to be just a list of numbers. In fact, I can see that, I can show that to you. So deck of, say, cards is indeed 0 1 2 3 4, because I'm testing my code. This is a good way to test. Now we can take one more example over here. Let's say I want to now do a deal with, let's say, 13 cards at once. So I'm going to deal 13 cards to one player. There will be totally two deals, right? So 13 13 13 13. When I run this piece of code now, this time toss took two attempts, but when I click enter, notice what happens. I get 0 until 12 going to the player, 13 until 25 going to the computer, 26 until, say, 38 going to the player. So that's fine, and then remaining going to the computer. So if I were to look at, let's say, length of, say, player cards, that is 26, and clearly the length of computer cards will also be 26. Now obviously you can set these parameters, you can add the jokers, you can add whatever, but so long as this n deals is an integer, you can see that this loop will actually work. In fact, we can also make this work for the vanilla case, where I say, well, look, every alternate card must go to, let's say, the player or the computer. I just set NCT to 1, and in fact that is also perfectly fine. Notice what happened here. 0 2 4 6 8 and all went to the player, 1 3 5 and so on went to the computer, which of course I could have done with just a single slicing. I did not have to do this here, but nonetheless this shows that the code actually works. Obviously, before I leave, I'm going to not, I'm going to sort of reset my code a little bit here. I'm going to say, well, let me just append the jokers. More importantly, of course, I'm going to comment out this part, right? So that I sort of, I'm clear here. I'm not sort of messing up the game. Let's see this working, say, once again. So just for this, for the sake of, let's say, for now, I'll set this NCD to 9 now, which means that I'm going to be making 3 deals, because remember, now there are 54 cards in the deck. I've added 2 jokers. 54 times, 54 by 18 is basically 3. So I'm going to be making 3 deals. 9 cards to one player, 9 cards to other player, then the next 9, and so on and so forth. If I see this working now, so I'll say Control C, Control D. Let me just clear this whole thing so we can see this. So when I run this, well, it's hard to figure out, but let's assume that, the first 9 cards went one way, next 9 cards went the other way, and we can be sure about it because we have seen this code working previously. Notice how we tested this, how we built this, and this has added a degree of interesting, coding practice here in our, let's say, in this project, right? I hope you found this interesting. In general, if you think this way of learning, where we build activities, we think about how we can enhance them, we put those enhancements in code to understand how things work. If you think this helps you to learn concepts better, understand how concepts are actually applied, look at our website, because we have many, many, many such examples. Take care. Thank you so much. Bye bye.